Nowadays, I'm best known for the podcast I host, the TWIML AI podcast. I've been doing that for about 4 years, 380 shows now. We've seen about 8 million downloads since the launch of the show, but at heart, I'm an industry analyst with a really keen interest in machine learning tooling and infrastructure. And while the podcast does cover a broad range of topics, everything from research to application, ML tooling and infrastructure is one that I am particularly excited about. I've interviewed folks on the machine learning platform teams at companies ranging from tech leaders like Facebook and LinkedIn and Twitter to traditional enterprises like Shell and Toyota and Two Sigma. I've also written quite a bit about this topic over the last couple of years, and last fall organized an entire conference, TWIMLcon AI Platforms, solely focused on the practices and technologies that organizations need to be looking at in order to deliver models into production efficiently. Ken, if you can go to the next slide. In addition to all of that, I'm also in the process of conducting a survey to really understand more deeply the way organizations and the industry are approaching machine learning development, deployment, and operations, with a particular emphasis on both processes and tooling. And I'm excited to share a little bit of a preview of some of the results of that survey with you to get our conversation kicked off. We recently closed the data collection phase of that survey and are in the process of analyzing the data, and we've got some really interesting early insights that play right into this conversation of build versus buy and platforms as a whole. And I think they say a lot about some of the challenges that organizations face as they look to scale machine learning, why they're investing in platforms, and what they stand to gain. And so I think, when I think about the conversations that I've had with organizations that are, on this journey of adopting machine learning, there is often an inflection point for organizations as they start to get serious about ML and AI. And I think, if you've taken a look at the Algorithmia paper on build versus buy, they talk about some of the stats and kind of the competitive imperative of ML and AI. So I'm not going to belabor that, but there's an inflection point that organizations kind of invariably get to, where they start small, which is encouraged, and the primary focus is on just trying to come to terms with the idea of building predictive models based on the data that they have access to in order to solve some set of problems in their business. And this is where a lot of investment was through about 2018, 2019. You can jump to the next slide, Kenny. But at some point, the value proposition is demonstrated in the organization, and focus starts to shift to getting models into production and seeing all the way through to the end of the machine learning workflow. And that's where a lot of organizations are today. This shift, this inflection point, I think a mass of organizations started dealing with this again in this 2018, 2019 time period. And one of the interesting things that we saw in our survey data is that as organizations look to scale their machine learning investments and operations and activity, whether it's because they're larger companies or because they're more mature and they're dealing with more models both in development and deployment, the time to productionalize models increases. You saw in the survey data that Patchen pulled up earlier, a similarly wide range of responses in terms of how long it takes to productionalize a model. Some of that I've also seen in the Algorithmia State of ML survey. I don't know if the Algorithmia folks, Kenny, if you've looked at this data by size of company or maturity. Maybe that's something that we can talk about later on. But that's one of the things that we did, and we saw that as the scale of an organization's ML activities increases, the time it takes to productionalize a model increases as well. And at first blush, this might seem counterintuitive, especially if you don't know much about enterprises, because maybe you think that the folks with the most experience, with the most at stake, are the least effective at getting models out. But some of the other data that we've collected, really starts to get at what's happening here. And I'll start to, we can look at that in the next slide. And so one of the questions that we asked was for respondents to identify the things that are getting in their way when it comes to getting models into production. And while when we look at this in aggregate, the responses were pretty broadly distributed, when we dug into the data and start to pick it apart, some pretty interesting trends emerge. Of course, we often talk about in machine learning the kind of the skill crunch and the lack of talent being an issue for getting really effective at machine learning. But one of the things that was really interesting for me here is that among the 15 choices that we offered folks to select from, we had choices for both lack of data scientists as well as lack of machine learning engineers. The responses here, when folks were talking about the lack of skills, it was lack of machine learning engineers by a long shot relative to lack of data scientists. And this is across company sizes and categories. And I think that says a lot about where the industry has come, and this, this inflection that I was speaking to earlier, where we're moving beyond, can we build models? And now there's this tension in how do we get these models out into the hands of the business and the users, the customers, et cetera. But other factors that are aligned with scale include the fact that with larger businesses, more teams, more people, and more teams are involved. So when we looked at the challenges stated by larger companies, we start to see things like dealing with internal alignment and getting stakeholders on board become significant issues that smaller companies, as you might expect, don't really have to deal with. Larger companies are also dealing with more data from more sources. Their models are more sophisticated. So we saw that while small and medium-sized companies aren't building as many models around computer vision, for example, the larger companies were. As you might expect, they are also more concerned with issues like governance and security. And so for larger organizations in particular, there are a lot of impediments to getting models into production that seem to corroborate the fact that it takes longer for them to do. Nonetheless, 85% of respondents to the survey were investing in machine learning or MLOps platforms to help them get models into production and to do so more effectively. And you can move to the next slide, Kenny. I'm not going to go through the details here. We asked about, whether they had one platform, multiple platforms, moving to a single platform, and there's some interesting data there. But the headline here for me is that organizations see technology as a way to help them address the challenges of getting models into production, and rightly so. And we'll go into a little bit, we'll double click on this on the next slide. We asked what folks saw as the primary benefit of investing in ML development and deployment tooling or platforms. And here again, we had around 14 choices, and the groupings were really interesting. Across the board, the top drivers for organizational investment is to address that point that I started out with. It's taking way too long for organizations to get models into production, and the primary drivers for organizational investment are, time to production, reducing or increasing iteration speed, reducing iteration latencies, and addressing scalability. Of secondary, the secondary cluster seems to be around issues like performance and reliability, model monitoring and performance management at the top of that list, but also reliability and model performance, model accuracy. And then the third cluster being what you might look at and see as C-suite concerns. So governance and innovation at a high level, security, explainability. I was actually very surprised to see fairness and bias reduction come in so low on the list of concerns, given how often I hear about it, but also how important it is. But it says that folks are really trying to wrap their hands around how do we get models into production more quickly as kind of the first issue, and then I expect they'll start to deal with these secondary and tertiary concerns afterwards. So this survey, as I mentioned, this is a preview of the results of the survey. If you're interested in learning more, you can visit twimlai.com/mlpulse2020, and I'll let you know when the full survey is available. I think this provides some motivation for investing in machine learning management and operations platforms. As soon as you do that, though, you have to answer the question, do you build it or do you buy it? And I'm going to turn the reins over to Kenny to share some thoughts on that before we enter the kind of the conversational part of our webinar.
Great. Thanks, Sam. Yeah, no, this is all really great data, and it aligns with a lot of what we've seen, both sort of anecdotally on the ground, speaking with customers and seeing how companies and developers are deploying this stuff, but then also from our surveys and our white papers that he was mentioning. A lot of this data lines up, but some really good nuance there. It's really interesting stuff. So I'll just start off with kind of introduction to myself. I do appreciate Patchen's intro, but just for context, I've been working in the AI and machine learning industry for nearly 2 decades. I started off in a PhD program in AI, way before AI was the trendy thing that it is now. After that, I worked both as a practitioner at startups and tech companies implementing AI and machine learning, doing computer vision, looking it up into apps and things like that. And then most recently, I'm the founder and CTO of Algorithmia, which is a platform for hosting, managing, and deploying machine learning models. And this this really came about from my time in grad school. You know, myself and my colleagues were developing new state-of-the-art machine learning algorithms, but they really weren't getting out into the world and into the hands of people that could use them. And now that in a certain sense, that's one of the benefits of academia, is that it doesn't necessarily have to be, you know, practical and oriented towards that. But in the world of machine learning, it absolutely was. And, you know, these tools and these models and these frameworks that are being built, you know, if they can get into hands of companies and you find that right application where machine learning really, you know, either enables your company to save a huge amount of money by automating something that would have otherwise, you know, maybe had to be done by human labor, or on the flip side, you know, just enabling new use cases that wouldn't be possible without AI and machine learning. You know, broadly speaking, I see those as the two really big categories of, you know, where ML can become a smash success within organizations. So today, you know, as I said, we're going to talk about build versus buy. This is a question that we see come up all the time. But before we dive into that, I kind of want to just ask a question of the audience. Just, you know, think about it amongst yourselves, or if you want to, you know, ask questions further, we do still absolutely encourage asking questions, and we'll address them during this presentation. But so the question I want you to ask yourself, you know, regardless of what your role is, whether you're thinking about founding a startup of your own, whether you're working in a department in a you know, a big enterprise, or anything in between, or maybe even just a small, you know, independent freelance machine learning engineer. The question that I would ask is, how are you actually going to deploy and host your models? And it sounds like a simple question, but there's not a clear path. And it's actually, you know, it ends up going down a rabbit hole of a lot more questions. And, you know, it's not the same as just hosting any other web service or traditional software type things. And there's a number of reasons for that, which we'll dive into. But, you know, ultimately there's going to be the question of, do I try to build this myself, you know, assemble components, take open source tools, take cloud services that are available, in addition to, you know, whatever tools and script and code that we write ourselves? Or do we go and try to find sort of an off-the-shelf solution that's tailored to this use case and is built for solving those problems? I mean, this happens in every discipline of software engineering, but I want to sort of zoom in on, you know, what are the questions and considerations when you're trying to make this decision in the world of machine learning? And so I want to start off by focusing on kind of these bottom numbers, the time to deployment that we have on this slide. And I'll start with the kind of the bold claim that if you go DIY, it will often, not always, but it will often take up to or exceeding 18 months to get from you know, starting your path down machine learning to actually getting a model deployed and running in production. Whereas I would argue that, you know, if you use purpose-built tools where they, you know, we've taken the time to think through a lot of these issues. We have the breadth of support to support the wide variety of frameworks and tools and hardware that's out there. You can get up and running much quicker. So the normal reaction to people of this is, you know, oh, 18 months, no, that's crazy. I can definitely get it done in less than that. And that's the argument that I would make here, is that that's actually the trap of DIY, is that, and this is a very common sort of bias with engineers, right, is, oh, no, I can just build that myself. It's not going to be that bad. You know, I'll use tools off the shelf and, you know, cobble them together and we'll get to there. So I want to start talking about this in sort of a narrative fashion, in the sense of thinking through, you know, as a company, what is their journey to machine learning? You know, maybe they have some data scientists already or some ML engineers, but let's assume that this company has no ML models in production yet. So, you know, hopefully they already have a use case. Hopefully they already have the data. We'll just assume those things. And, you know, maybe they have a data scientist working on their laptop, building models in Jupyter Notebook. So then the question is how do we get that into production? Getting the first model into production is not necessarily rocket science. There's a number of ways you can do it. You know, sometimes the simplest is going to be you spin up an EC2 instance, you load up your model onto it through any number of mechanisms to do so. You know, maybe you add it to something like an auto scaling group so that it can scale up and down, and you're off and running. So that's something that a competent engineer can do in a matter of a couple weeks, I would argue, pretty confidently. The problem is that that's just the first model, and it's just the first version of that first model. And really the complexity comes in after that, when you start considering kind of some of the things that come around it. And so let's go over to here. So things to consider as you're deploying your first, second, third, et cetera, models. So obviously duration is a big one. As I was saying, DIY can be deceptively easy on the first one, but then there's the question of what happens when you want to, we won't even say the second model right now, what happens when you want to deploy a new version of that first model? So, again, there's all sorts of tools, and I don't want to overgeneralize on all of them, but, continuing with the example of, okay, we've got something in an auto scaling. Maybe it's containerized in one of those container services, but then you start running into various other challenges. But I want to roll out this new version. Well, do I need to create a new auto scaling group? Do I need to create a whole new deployment just for this new version? Or if I deploy it and essentially overwrite the model or deploy into a new deployment and it just does a rolling deployment, how am I going to manage that transition? In many cases, you want to keep both the old version and the new version running so that you can do comparisons, so you can do A/B testing, so you can do all these sorts of things. And that's starting to kind of hint at some of these challenges that start to come up that in many cases exist for traditional software and have been solved in that world. So there's a lot of best practices, which I would argue, as much as machine learning is a new field, it's a green field, and who knows what it's going to look like, later this year, next year, or 5 years from now. There's a lot of inspiration that we can draw from what I would say called traditional software engineering and best practices and techniques around that. So even just basic things like source control management, CI/CD, all these deployment tools, testing, unit tests, in addition to sort of integration tests and all those sorts of tests that have been developed, and observability. And again, there's all these things which have become table stakes in software development. If you were going to go start a software company today and you said, you know what, I think source control management, Git, I think that's overrated, CI/CD, no, like I don't need that, you'd be pretty much laughed out of the room. I mean, no serious engineer would think that that was a particularly good idea as a way to architect your stack. But in the world of machine learning, these things are largely absent. It's not uncommon, even at very large, respectable companies, to see data scientists developing models on their laptop in a Jupyter notebook and not even checking them in source control. So you have no history, you have no lineage of or accountability of how are these models generated, what data was used to generate these models, and what was the source code that was used both for training and separately, what is the source code that is actually doing the inference and the service. So these are some of the unique characteristics of machine learning that you have to layer on top of those sort of existing challenges of software development. So the other really big thing that's obvious and different about machine learning is going to be the hardware requirements. So there's unique hardware requirements for ML, not the least of which is GPUs, but it's more complicated than that. Everybody wants to containerize their workloads, and Docker and containers and C groups and all that are fantastic tools. But when you get into the world of machine learning, that abstraction of Docker as sort of a lightweight VM-like thing, it starts to break down because, unlike having a bunch of VMs, which each have their own Linux kernel and drivers and all that, when you have a Docker container and a containerized workload, and multiple ones of those running on the same machine, they're all going to share the kernel. And so if you have things like the NVIDIA drivers, if you have things like CUDA and CUDA, some of those components have to live on the host, not within the Docker container. And so that leads to a lot of challenges, and you may not be able to use some of the more traditional container services, things like ECS and all that, at least not without jumping through a fair number of hoops in order to be able to actually just even run your machine learning workloads. And I haven't even yet gotten to some of the challenges, going back to Sam's point of, why do large organizations take so much longer to get into production with their models? Now, again, this is not necessarily an uncommon thing. This happens with traditional software as well. But there's so many more hoops to jump through that it's not just a matter of, oh, take my model, put it up on a EC2 machine, and create an auto-scaling group. You need to ensure compliance. You need to ensure security. Going back to what I was saying, you need to have an audit trail of how is this model generated, who deployed it. In many cases, for things like SOC compliance, the person who's deploying it has to be a different person than who's actually developing the code, to make sure that there's at least two sets of eyes that are responsible for it, so that one person can't deploy a model that maybe isn't doing what it's supposed to do. In the worst case, there's actually threat models that are somewhat unique to machine learning, where it's not just the source code that defines what's running, but there's also this model file, that binary model file. And if you have a developer working on their laptop and they just upload a model as a binary, and you don't have an audit trail of how was that model generated, there could be all sorts of bias introduced to that model, whether intentionally or not. There could be things, it isn't executable in a certain sense. We don't always think of it that way, but so especially in big organizations, especially in regulated industries, there's a lot more considerations that go into these questions. And then there's all sorts of unique management challenges too, because the software development lifecycle is subtly different than the machine learning lifecycle. The biggest of which is lean software development, agile software development, all that. It's all about the feedback loop of how quickly can you iterate, because speed of iteration is everything in technology. And machine learning is no different, except in some ways it's often faster. Whereas you might have people developing code in traditional software, and that can take weeks, and there's reviews and all that. In a lot of cases with machine learning, you'll do nightly retraining. And so that introduces, first of all, many, many more versions of a model that comes out very rapidly that all need to be managed. And you need to be able to run testing and things like that. And so I also think it's interesting to ask the question of what is unique about testing, or what would be the analogy for testing in the world of machine learning? And unit tests and things like that. Machine learning engineers and data scientists are very focused on things like accuracy, loss functions. But I think it would be great if we were in a world where you could run suites of tests against your models. So it's not just about the bottom line, 90% accuracy over the whole data set, but how is it performing on subsets of the data? How can you ensure that over time, you're not developing bias slowly in your model, whether because of data drift or model drift or anything like that. So just kind of wrap up and kind of show some of the decisions that go into it, and make the sort of final case that there's a lot of decisions to be made when you're trying to build the system. I'm not going to go through every single thing on this slide, but when it comes to the model deployment side of things, there's different languages. There's Python, there's R, there's Java, there's all these things. There's all the different frameworks. Just a couple years ago, it was TensorFlow, and now if you look at the statistics, more than half of the research is papers are being published in PyTorch. It certainly has kind of a lot of the community momentum. And similarly, who knows what's going to be the popular framework a year or 2 years from now. And so if you settle on a system where you're locked into a particular library or framework, you're not going to be doing justice to your data scientists who want to use the best tool for the job. And the best tool for the job in NLP is not necessarily going to be the same as the best tool for the job for computer vision or for time series or for things like that. And then you get to the questions of how do you do monitoring, how do you do alerting, how do you do CI/CD, how do you do governance? Who is allowed to deploy models? How can you ensure that only the right people within your organization have the right to access those models? How can you ensure that they can only access the data that they're supposed to? And so I think a lot of these things are what contribute to what Sam was showing of large organizations often having a lot more of these considerations up front that they know they need to comply with. Whereas with smaller to mid-sized organizations, you may be able to get up and running faster, but I would definitely argue that over time, you're going to want to add more and more of these things. And so the more you can have a system that's designed for this and recognize that and start with that and not have to build it yourself, so that your developers can focus on building things that are actually relevant to your business, not reinventing the wheel on hosting and deploying machine learning code, I would argue that there's a big win there. And the sooner you can get to value and deployment, that's really how you get success with machine learning. And that's ultimately what I think matters is how can we prove the value of this, because I'm a huge believer in AI and machine learning and the value in it, and I want to see more of it in society, and I want to have cooler toys and things like that. And the only way to ensure that is to make sure that businesses are successful with it so they continue to reinvest in this industry. So with that, I'll just mention that first of all, we have a white paper out there, which was referenced by Sam. I think it's also possibly linked and associated with this build versus buy webinar. But that has a lot of more specific statistics and details backing up kind of a lot of points that I was making here.
Awesome. So now we'll transition into more of a discussion segment for the remaining time. I'd encourage those of you in the audience who have questions to submit them via the questions panel. I'll be keeping an eye on that. I do have a few of my own to get us kicked off. I've come to enjoy the opportunity to ask experts questions via the podcast, and we'll be doing a little bit of that here. The first one that jumps out at me is going back to this build versus buy white paper, and it is available in the handout section of the GoToMeeting control panel for those that haven't seen that yet. But you've got in there a project plan for folks that might want to take the build route. And you break that up into a bunch of phases. Is pretty detailed and interesting, but you estimate 28 months of effort there. And I'm curious what assumptions you're making in that estimate, particularly in terms of the tech stack. Like, are you assuming that folks are building it from scratch, or that they are building on open source? What all goes into that assumption?
Yeah, I mean, it's largely, from the data and from what we see anecdotally talking to customers, is that's not, 18, 22 months, those are not unrealistic things to see. But we see people taking different approaches to it. There are kind of the open source technologies. Some companies will go, say the Kubernetes route. They may already have some level of that for other services in their organization. On that path, there's going to be a bunch of challenges, not the least of which is the hardware and the drivers that I was making reference to earlier. And also even just Kubernetes is kind of a beast to maintain itself as well. Algorithmia is built on top of Kubernetes as well, but it offers a ton of benefits, but it's not easy by any means, and there's a lot of new paradigms and things to consider with that. Another direction that we see people go is the cloud providers, the major things, the Google Cloud ML, the Azure ML, the SageMaker kind of approaches, and often when people say build, they don't mean write every code from scratch up from assembly the whole way up the stack. They're saying use as much things off the shelf as possible, including tools like SageMaker. And that can certainly offer a leg up. Absolutely. I would argue that one of the things, and this is not I don't want to speak too broadly about every tool, but a lot of these tools, they're a bit more opinionated about the way that they work, the tools and the frameworks, and how you build these things. And there's a trade-off between deep, opinionated tools and integration, and the kinds of things that they can do as a platform. Then, putting up pretty graphs and showing things of how the training is progressing and things along those lines. But there's a trade-off of, if you're very opinionated about the tools and how you build the frameworks, it can make for a really good demo up on stage. And if you're staying within the lanes, it can work really well. What we see though a lot is that may work for your first model, but as you go deeper into that, and as it's driving more value to your company, you're going to want to customize. You're going to want to really fine tune a lot of the parameters, a lot of the performance, or maybe you want to really squeeze everything you can out of the model. Maybe you want to use one of the packages like TensorRT, or things like that really optimize the model for your particular hardware. That becomes a lot more difficult if you are in this sort of high-level abstract system. The other thing which I see as people start going down that road, they can follow through the tutorials and it works, but then they start running into these challenges. There's also the thing of, I don't think that we're headed towards a world of a one-stop solution end-to-end, where everything from the training to the deployment to the management of these things is all necessarily the same tool. And it's just kind of been the history of software that, it's not the case that we've moved towards one-stop shops of these. The more valuable a project is, the more people you have working on it. You want to choose the best tool for a job, which is why, you don't tend to see people using, Amazon end-to-end for everything, all in one solution. You still see people using GitHub and GitLab for their CI or for their source control management. People using Jenkins and all of these sorts of things for their CI/CD. Ultimately, you want to choose the best tool for the job. And so I think in many cases it can make sense, use SageMaker, use these tools, use these training platforms for what they're great at. I would argue that where they're not quite as strong and where we've been thinking about this problem a lot longer as a company as at Algorithmia is the deployment, the management, the collaboration between multiple developers on your team. And so that's where I think it can make absolute sense to combine these tools in that way. But these questions come up after you've started going deeper down that world. So there's different paths that people take, but I would argue that they all end up being longer than anticipated.
Mm-hmm. In your slide, you showed I don't know if you'd call it an architecture diagram or just kind of a diagram of the various concerns that folks need to be thinking about when they're trying to deploy a model. Clearly the organization that is deploying the model, whether they've built their own platform or they buy one, they still need to understand a lot of those details. And so Mel asks, what kind of team needs to be in place in these different scenarios? In other words, even if I, buy off the shelf, I'm still going to, what do I still need someone who knows how to kind of dig into the details of Kubernetes when something's acting up, or where do those lines get drawn?
Yeah, no, absolutely, and that's definitely a pain point that we see firsthand with customers. Oftentimes is who's responsible for what, and there's a number of chefs that essentially have to get involved in the making of an ML stack. You've got the data scientists that are actually working with the data and experimenting and building the models. There's this ML engineer kind of role, which is, how do you actually, what is the software engineering side of machine learning? How do you actually deploy these? How do you get these things out there? And I saw this firsthand when I was in academia, many brilliant theoreticians, pushing the state of the art. But that's a very, very different skill set than knowing how to effectively deploy code in a scalable and reliable way. And frankly, it's not at all the same skill set. There's a reason why in traditional software engineering that DevOps has become its own discipline, that with its own conferences and its own best practices and all that. And so I'm definitely a believer. Look, I think data scientists can certainly benefit from understanding more of the engineering and how that's going to go there, but let them focus on what they're good at. Let them focus on, the art of tuning a model and understanding those parameters and keeping up with the state of the art of research and what's coming out and what pre-trained models are out there that they can leverage. And then let people who want to live in that world of infrastructure and scaling and reliability and Kubernetes and those sorts of things, let them focus on what they're good at. But then it doesn't necessarily end there. To your point, there's the business owners, there's the actual the executives or the project leaders, there's the budget. There's that, and then there's also the traditional DevOps. And we often, it's not uncommon to see a DevOps team that's frankly a bit too excited to go build out their own machine learning platform. Because like
Kubernetes.
Yeah, exactly. And you get to learn new things, progress your level up your own skills. But again, that can be a trap where if the priority for the business is to get to production and to get value. And so I think that that's what people should really focus on. As fun as it can sometimes be to kind of build these platforms. So.
Yeah, there's an interesting challenge that organizations face where it's easy to deride folks as kind of biting off these projects because they're fun or because they're resume builders, but there is a reality that organizations are competing for talent, and talent likes to go places where they'll get transferable skills, and building platforms like this can be a transferable skill. Is that something that you've had to kind of work through with customers? How do they make it a kind of an enriching experience for their teams?
Yeah, I mean, I think I could debate some parts of that in the sense that, is it going to be transferable if you build your own system that nobody else is using? And, we've seen that. I mean, there's one example at Michelangelo at Uber. They're obviously big enough and at scale that, sure, they can afford to build their own ML deployment and management framework. But no, very few, I think it is open source, but very few, if anybody, people outside of Uber are going to be really using that. And so I don't know if that's going to be as transferable there.
Right.
And
or
also,
setting up the engineers to go start their startup.
Well, yeah, potentially. But, even in DevOps, I think that people appreciate now using tools off the shelf. I mean, if you talk to DevOps engineers, they're fanatics about their tools. They love, finding a good tool that solves their problem. The goal isn't to recode everything from scratch or build things from scratch. It's to find the best tool for the job. And if you talk to, people who are fans of HashiCorp or people who are fans of GitLab or whatever it is that your tool of choice, right? People love that. And so I think that as the industry matures and all that, and people kind of find those tools that they like and that solve their problems and enables them to move faster and do their job better, and ultimately, deliver on the metrics that they're being judged on. Ultimately, I think that that's what matters more than, is it fun, right?
Mm-hmm. You mentioned earlier, you kind of broached this issue of opinionated platforms versus more kind of open-ended or flexible platforms. This is something that I see many teams struggling with. There's on one side a desire to support any tool that any engineer might want to use, or put another way, the right tool for the right job. But at the same time, there's a need to support all of those tools and have people on the infrastructure team that understand them to a degree to be able to debug issues when things go wrong. I'm curious if you can elaborate a little bit on how you see folks navigating that, and also does that change to what degree does that equation change in build versus buy?
Yeah, no, I mean, there's definitely trade-offs there of, more flexibility and more breadth versus more opinionatedness and, more kind of focus on there. And I do think that, you want a bit of both. And so, for example, Algorithmia, we have these things called package sets where we define things like a TensorFlow or a PyTorch or Hugging Face for transformers and things like that, right? And companies can choose which they may make available or not. We support 8 languages, but in a lot of cases, it's really just Python and maybe R. So I do think you want to narrow it down. I mean, no company wants to have to support 12 different languages and have the the shared knowledge of how to support and maintain all of those things. But I do think that if you're too opinionated about it, and if you tie the hands of your data scientists, that's not going to work to your advantage. If you made a decision by committee 2 years ago, which would have been a totally reasonable decision, that TensorFlow is the way to go, that's what we're going to support. We're going to do it on X Cloud, and we're going to use this tool and that. that's fine, but you see all the time, Facebook research, Google research, publish new models, NLP transformers as a great example. The nowadays in a lot of machine learning models, you're not just building one model purely from data, just from scratch. In a lot of cases, you're combining multiple things together. So that could be transformers of NLP, that could be vectorization, word-to-vec type things as a first step of an NLP pipeline. Or it's, off-the-shelf models, these mega models that have been trained with thousands upon thousands of hours of compute, like GPT-3 and all these things, which are, really compelling and pushing the state of the art. And, if you committed 2 years ago to, a particular framework, you might not be able to adopt those very easily because the pre-trained models are not always available for everything, and different frameworks excel in different areas. So I think it is something to consider on how broad you want to go there, but the industry is just evolving so quickly that I think it would be a mistake to be too opinionated. And I guess to the other question is, if you're building yourself, then you're going to have a team and people maintaining that and monitoring the state of the art and all that. Whereas, if you have a company or a tool that's really focused on this, that's where, and it doesn't have to be Algorithmia, but we're monitoring all of these things. Like, so we, when TensorFlow 2.0 was coming out, we were testing out every beta before it came, so that when on the day that it released, we knew that we were going to be able to support that for our users. And so, you can do that in-house if you want to do it, but it's resources, it's cost, and it's time. And so, I think that there's benefit of having one company or one tool doing that groundwork for the benefit of hundreds of companies, instead of, you having a team in your own company doing it for just one.
In our survey, one of the technologies that folks seem to be most excited about for addressing some of these issues is Kubeflow, which is a project that rides on top of Kubernetes. Can you maybe speak to the role that Kubeflow plays in here? Is it something that you support, and where do you see it play in the buy decision versus the build decision?
Yeah, so I mean, Kubeflow is cool, and I'm a huge fan. Like I said, we build on Kubernetes. Like, I love open source. What I would say about it is two things. So first of all, like, I'm rooting for it, but it's a young project. I have to check, but I'm pretty sure even like the first commit was about 1.5 years ago, and it wasn't like a mega commit of just Google code dumping. Like, no, literally, like, that's kind of when they started building it up from nothing, which is fine. They're investing a ton in it, and it's come a long way, to be sure. But it takes time for open source projects to mature. Is kind of the fact of the matter, and especially for enterprises that have requirements like governance and auditability and these things. And so, I'm not the world's biggest Kubeflow expert, so I'm sure you can build a lot of those things on top of it. But it's getting figured out as we speak. And we do support deploying from Kubeflow to Algorithmia. So again, it can make a lot of sense if you already have a Kubernetes cluster. You could be doing your training there through Kubeflow. And again, I don't want to misspeak on a project that I'm not totally expert on, but they haven't really focused on the deployment and the scaling and the management side of things, which is one of the reasons why built into Kubeflow is this ability to deploy out to external services, such as. And so that's I think over time, open source catches up, but it takes a long time. For frankly, a decade or more, the proprietary tools are going to lead in some of this enterprise space, and then over a long enough timeline, yes, I do think that the infrastructure becomes more commoditized by open source, but I just don't think we're there yet today.
All right, we've got time for one more question. Jan is asking about continuous quality for models. This is something that when I was pulling together the ebook Definitive Guide to Machine Learning Platforms, there was a lot of technology and a lot of different aspects of the end-to-end process, but one that at that time didn't have a lot of kind of options was the detecting drift. A lot of people tended to build their own, often on top of low-level tools. What do you think are the main approaches and considerations there?
Yeah, well, like I said, I mean, I think that we can draw inspiration from traditional software. Like I love the idea of asking, what is the analogy for unit tests in machine learning? What's the analogy for integration tests? How would you do A/B testing and progressive rollouts of models as you see, is it performing well? And that's one of those things where, as I was saying, the more you can just keep a library of all your versions of your models so that you can call the previous version or the previous 5 versions and be able to compare them. I think that's really key because there's new failure modes with machine learning that are possible, right? Even if the code and the model itself doesn't change, if your underlying data distribution does change, that can in itself be a problem. Like, I give a sort of visual example in some of the talks that I give of, maybe you trained a fashion detector model to recognize clothing in summer. But then winter rolls around and suddenly, people aren't wearing the same things. How do you validate that in machine learning if you maybe haven't even deployed any model? CI/CD tools they're typically only going to run when you do a git push, right? They can be configured, but like for machine learning, it might be a sort of thing where you want to run it nightly, and that's subtly different than how you would use the tools in sort of traditional software.
Awesome. Well, we've had a lot of great questions at the top of the hour now. Patchen, do you want to close us out?
Yes, thank you, gentlemen. That was a great set of questions. I still see questions coming in. So I know we went a little long, but engagement seemed high, so that was great. Thanks everyone for attending today. And thank you, Sam and Kenny. We will follow up with everyone and we'll send you a recording or access to a recording of today's webinar and an invitation to pick up our build versus buy white paper on the topic. You can also find that on our website if you're impatient. And I'll do my best to answer all the questions that went unanswered from our feed. So we'll send that back out to everyone. Thanks, everyone. Have a great Tuesday.
Great. Thanks, everyone. Thanks,
Awesome.
Sam, for the conversation.
Everyone. Thanks, Kenny.